Hello everyone, welcome back to the 12th video of this series where we are solving past 20 years of JEE advanced questions for the kinematics topic. If you are following my series, you must have gone through the solution video of this problem. So in this video, I am trying to solve the same problem again with a different approach, okay, a quite beautiful one. So previous one was mathematically oriented, where we break down the problem in x direction, y direction, and saw that this particle was doing SHM in x-axis as well as in y-axis, and in z direction it was performing the uniform motion with constant velocity. Okay. So I would insist everyone to stick to this video and see how beautifully we could have solved it. Okay, so let's continue. So it was given that force is minus kx I cap plus y j cap. Okay, force was given like this. If I draw this, okay, if I try to visualize like what this equation is trying to tell me, suppose this is my x-axis, this is my z-axis, and this is my y-axis. Okay, when particle would have been here, okay, I mean in xy plane and z coordinate as 0, the direction of force must be towards the origin. I hope everyone agrees with this. Why? Because what is x I cap plus y z cap? If this coordinate is x comma y, I'm drawing it separately again. Okay, x I cap plus y j cap. This is nothing but position vector. Okay, position vector from the origin. So if this is my origin and this is x comma y, x I cap plus y j cap looks like this. So definitely minus x I cap plus minus y j cap will look like this. Okay, where this is origin and this is x comma y. So I am saying when the particle was in xy plane, direction of force will be this. I hope everyone agrees with this. When particle will be here having some z coordinate, again the direction of force is independent of z coordinate. Okay, direction of force is again dependent on x and y. So if I will take projection of this in xy plane, suppose this is my projection. Okay, this is my projection. Again the direction of force will be this line, and if I take this parallelly, direction of force should be this, because at every point of time direction of force is only dependent on x and y coordinate, and that too from the origin, like in the negative direction from the origin. Okay, so if suppose particle is at this point, okay, having some coordinate x1, y1, z1, direction of force will be independent of z cap, and it will be in the direction of minus x minus y, which is this direction. Okay, so at every point of time what is happening, suppose this is my z axis, direction of force is towards the z axis. Okay, direction of force is towards the z axis. So can we say, since force is always towards the z axis, torque along the z axis will be 0, because force is always penetrating towards the z axis. Okay, it is crossing the z axis. I hope everyone is able to visualize this, that torque along the z axis or z axis is 0. Why? Because force is always crossing the z axis. Okay, since torque along the z axis or z axis is 0, angular momentum angular momentum along the z-axis will be constant. Angular momentum will be constant. If angular momentum will be constant, what does it mean? It means irrespective of time, angular momentum along the z-axis should remain constant. So let's, whether the time is at t equal to 0 or time is t equal to pi by 4 or time is t equal to infinity, it doesn't matter. Since force is always passing through the z-axis, angular momentum should remain constant. Okay, so what is angular momentum? Angular momentum is r cross v. R cross v will remain constant, and if I draw, r cross v is nothing but x I cap plus y j cap plus z k cap. This is my r cross velocity. Velocity vx I cap plus vy j cap plus vk k cap, vz k cap. Okay, this will be my r, this will be my velocity. So r cross v will be this. Z component of this will be x vy minus vx y. I hope everyone knows the cross product. Okay, so angular momentum in z direction will be x vy minus y vx, and this is exactly what we had to calculate. So actually we had to calculate the angular momentum in z direction, and angular momentum in z direction will remain constant throughout the motion, because force at every point of time, force is crossing through the z axis. So torque along the z axis will be 0. So angular momentum along the z axis will remain same, and x vy minus vyx is nothing but the angular momentum in z direction. So we can directly calculate it at t equal to 0 because it is constant. So at t equal to 0, x coordinate was 1 by root 2, y velocity was root 2 minus y coordinate was root 2, and vx was minus root 2. Okay, so if you calculate it, 1 minus 2, which is 3. This was the way we could have solved it. Okay, so it is not necessary that we can think like this during exam time. Okay, first approach was still okay, but this is one of the very beautiful way we should have thought. Okay, so the lesson which I learned and everyone should learn is, if we are getting this kind of parameters, x vy minus y vx, cross product should come into our mind, and we should see if cross product is there. Generally we see cross product while we calculate torque or angular momentum, or what we do calculate, something like this. Okay, so this is a kind of hint that we could have thought about angular momentum, and particularly in the z direction. Okay, similarly, what would have been the torque in angular momentum in x direction is v y vz minus z vy. Okay, this was our angular momentum in x direction. If this was the parameter, we could have thought, is there any torque in the x direction, or which should remain constant, or something like that. Okay, so I thought I should create this video and share with you guys. I hope you guys have learned something through this video, and let's meet at the next video with the new problem. Okay, thank you.